So I'm going to continue on with some examples. This example I'm going to talk about is now some sort of policy changes that we can use to try and control pollution levels. So we have two different policy incentives that we're going to be looking at here. The first policy incentive was a financial incentive to generators to use low sulfur coal. And the second one was a mandate, so a regulatory approach to implement some changes. So what we want to know is, if we had this mandate, was this effective in reducing pollution levels or emission rates? So what have we got here? So we've got some data on how this all worked. And I guess there are a couple of things that we can look at here. You can see that when the tariff comes in 2004, and you can see that we do start to see a change. But you might say, well, actually that, if you look at that line, it doesn't look like there's a great change in the slope of the curve. It looks like it's just going in its similar way. And then we see this change in 2006. And then I think, at least to me, you start to see this real change. So we've put on this mandate. So we're not giving a financial incentive. We're saying, actually, you have to do this. You have to use this particular kind of technology. So sometimes those kind of mandates of specifying a technology go badly because we've locked people into something that might not be the least cost way of doing things. But, we sometimes know what's a good way to do things. So often in the energy business, there's a well-established technology. So putting on these scrubbers might have been a well-known policy. And we have some other things that start to come in, some different incentives that are going on there. But if you look at the slope of the curve, it seems to me when the mandate starts, things start to be moving along. So let's have a look. What have we got? We're basically saying that what we want to do is say we're going to have some regulation. Here's my power station. It's burning some coal, generating some steam, and getting us some energy to drive some turbines. But we have some gases going out, and we're going to, instead of just letting these gases go out the smokestack, we're going to run them through a particular scrubber process. All right, so that's the nature of our setup. Is this kind of activity, is this mandating of the use of these scrubbers going to be something that reduces pollution levels? Okay, so what have we got? Well, we can look at our data. So in our case, we're going to think about this where it might be most useful to look at before and after. So we're going to say measure before. So this is going to be when there was a financial incentive, but before the mandate came into effect, and after the mandate. So there's still going to be the tariff incentive, but we've got now this mandate, what we're going to do. So the way that we want to look at this data, it's paired data, and we're just looking at the north region here, is horizontal box plot. And I would draw your attention to this guy. So if we look down here, we've got the mandate period, we've got the tariff period minus the mandate period. So what that means is if this number is less, so the sulfur dioxide levels are less in the post-mandate period compared to the tariff period, because we've got the tariff minus the mandate, these would be positive. So most of the values, it's telling me most of the values are actually lower after the mandate. So that's a very good sign that the mandate had some effect. You can see that some of the observations go the other side, but look at where the mass is. So that's 50% of the data here in the box. There's 25 and there's 25. So we look at that, a good chunk of the data is definitely looking like the mandate had an effect. So for me personally, I find the visual very convincing. But of course, the convention is to have a formal test of this. So we're going to implement our formal test. So we have this sort of setup for paired t-test. The mean of different series is 0. The alternative, the mean of the different series is not 0. Same format that we have for everything so far. Alpha is equal to 0.05. Conduct the paired t-test. So let's have a look at what we get. So I put my data in. I've got with my data set. Apply the t-test. It's a paired t-test. And we look at the p-value. So we see that the p-value is very much less than 0.05. And we know that the difference is 207, and we know it's going to take the first value minus the second value. But because we have our box plot, we know which way that the difference goes. So we can also look at our confidence interval. So what is this telling me? It's telling me that the mean difference after we put in, this is telling me the mean difference after we put in the mandate. So our policy of having a mandate has reduced emissions levels by 207, and the reasonable range for thinking this, so the plausible range, so bearing in mind that we've got a sample of data, is somewhere between around 150 and 260. So that's our best guess, that's our point estimate of our guess, and we look up here and say, well, the reasonable range, the 95% confidence interval, 153 to 267. So we've rejected the null. So we want to say something about, what was the policy impact. We might then want to look at some other things and say, well, how much did it cost to implement this? How much were those scrubbers? Was this a cost-effective policy? Could we have got an even larger reduction through using some other means? Right? So they're the questions that we would go on and ask. But in terms of our test, we've seen, yes, that there was a reduction in pollution levels. And of course, we can also implement this as a single sample t-test. So if it's the north minus the north tariff period, north mandate period, single sample t-test, exactly the same data comes out, because when we have a paired t-test, it's conducting the same as a single sample t-test on the different series. And so that's a little bit dated data. If we look at more recent data, the amount of red here is less. So we have less pollution in the more recent levels. And that's a sign that there's continuing policy effectiveness. Now, a related topic to this, so we have sulfur dioxide. We've also been talking about PM 2.5, so this small stuff. So the setup here is that there was no published data in China for the pollution levels. So people are a little bit concerned about these small particulates. They can cause a number of respiratory problems and result in loss of life. So we are quite concerned about the level of PM 2.5. And there's a US embassy. And so they installed some monitoring devices and started tweeting the results. So all of a sudden, there was some independent source. Well, if you're Chinese, do you trust the Americans? Are they trying to do something forgery? But it caused some change, okay? So these guys are putting out what they think, and at a minimum, they've got some view about what they need for their public servants. This seemed to be saying that pollution was worse than the official Chinese data. So we did end up having China establish its data. So it had to make some steps in this. And then there's this other one that's saying that, well, we've had some changes in pollution. So that's this sort of winning the war articles that have been around. So there's some literature on this that you can look up. So what are our guides? So these are the things that we're worried about, these very small particles that can get into your lungs and cause some damage. So our first setup is where we have the Chinese EPA sample and we have the US embassy sample. Now, we're not sampling at the same place. So it's not that we've got two measurements in the same location, different locations, so we don't have pairs here. Right? What we have are two different data sets. Yes, they're in the same cities, but they're not on the same street corners, so there's no structural relationship that we can rely on. So because we have two samples, we're going to have a two-sample t-test. We're going to have a few steps with that. So we're going to have a visual for it, which will be our box plot. So two-sample box plot. We're also going to have a variance ratio test to decide what kind of t-test to implement. So away we go. We have our visual. Now, to me, I look at this and I'm not super convinced. Yes, the embassy sample is looking a little bit higher, but it's not a convincing picture there. If you look at the medians, they look pretty close. There's a significant amount of overlap in the box plots. Maybe there is no difference. Right, first step, let's have a look at our variance ratio test. So we need to implement our test with a null and an alternate. So the variance for the EPA data is the same as for the US embassy data. Alpha 0.05, p-value test. Let's go and implement our test. So I have my test in here. So this is my data set, the PM25 or PM2.5. It's just how I've labeled it. It's a variance ratio test, and these are the two columns of data in my Excel spreadsheet that I've read into R. And I look at my p-value, and my p-value is 0.3. So I do not reject the null that the variance is the same. So it means when I conduct my t-test, I'm going to use the formula for when we have equal variance. So I now set up my formal test. Okay, the mean of the PM, of the PM 2.5 in the EPA is the same as the set for the embassy. So these two samples are drawn from a common population. You can see I've used a little bit different language for this, just showing you that there are some flavors on this. I don't mind if you say the mean of group 1 is equal to the mean of group 2, as long as you know that there are two means that you're comparing, that's okay. Standard setup with alpha, and we're going to implement the t-test. So what do we get? So with my data set, t-test, EPA, embassy, variance is equal to true. Look at my results. My p-value is above 0.05. So what do I conclude with this? That I have insufficient evidence to conclude that there's a difference between the EPA data and the embassy data. So in this case, it says, look, I have no evidence that the Chinese EPA is misrepresenting the pollution level. So that gives me some confidence in the data. The next one we want to look at is this idea that's been promoted, winning the war on pollution. So this example is talking about taking samples at two points in time from the same China EPA data set. So that would mean that we have paired data, and it's saying if we're winning the war on pollution, we would see that the mean pollution level in 2013 would be less than the mean pollution level in 2015. So we're saying, is there a difference? Paired data, so we're going to go for a paired box plot. And again, gee, I'm not convinced on this one actually. So just from the visual, I wouldn't feel that I feel especially confident that I know if there's a difference or not. Yes, most of the data is sitting on one side, and if you think about this, which way does it go? It is 2015 minus 2012. So if the pollution level was higher in 2013, so in the past, when you have the 15 minus this, you get negative values. And I do actually see that many of the values are negative, or most of the values are negative, but it's hard to visualize exactly over the zero. So maybe there's something going on. I really do feel that I need a formal test to make some sensible conclusions about this. Just a visual plot is really not sufficient. So let's have a look at this. The mean of the different series is 0 is my null. The alternate, the mean of the different series is not 0. Alpha 0.05, p-value decision rule. Hopefully you're getting really bored of hearing this so that you can know, yes, I know, I set up the null. I have alpha as 0.05. I know if it's less than 0.05, I reject the null. I know. You can stop repeating yourself. I've got it. But let's look at the results. So we have our data set, t-test, paired, embassy 13, embassy 15. Sorry, I'm using the embassy, not the EPA data. It doesn't matter. It's the same story. And the p-value is 0.12. So what do we say? We say there's insufficient evidence to reject the null. What is the null? The null is that there's been no change in pollution levels between 2013 and 2015. So we aren't winning the war on pollution. So remember, when we looked at this plot, it was a little bit hard to see. Were we exactly clear? I think that there is, there's some evidence that what we're seeing here are some differences. It seems to me that many of the observations show there has been a reduction in pollution, but we haven't come up with a statistically significant finding. So something we're going to have to start thinking about a bit more is how much evidence do we need to get a statistically significant finding? But right now, it's a good time for a break.